Hello, and welcome to a little video about the first topic of KC4, our very last unit for semester 1. The first thing that we need to discuss is something that you've heard used by a different name. It is average rate of change, and that you called a long time ago, back in the day when you did middle school, not too long ago, I guess, we called it slope. So it's the same thing. But average rate of change can be applied to any sort of graph, so it doesn't necessarily have to be a straight line. So the average rate of change is that straight distance between 2 points. And when we look at a graph, the best way to do it is to start with the left point. I don't know why I started with an F there. Left point, and we look from the left point to the right point. All right, so in this little example, we have the left point right here, so it's on the left side of our graph, and the right point is right here on the right side of our graph. To get from the left point to the right point, we do rise over run. That means we go up or down, depending on which way we need to go from left to right. In this case, we're going down. And then to the right. So we're always traveling to the right, all right? So the rise here, which is actually going down, is -4 because we're going 4 down. And then we're going to the right 2. We can simplify this, dividing both the 4 and the 2 by 2 to get -2 over 1. So we always want to simplify when we can, and that is our average rate of change. Let's try doing some on our own. All right, number 1, let's calculate the average rate of change for this function. All right, so the average rate of change, I'm going to write down, whoops, what did I do? Okay, there we go. So for the average rate of change, I'm going to rewrite the rise over run because I like seeing it. Rise over run. It also reminds me which way I'm going. Okay, now it doesn't matter which 2 points we pick, but the way that I'm going to choose is I'm going to pick points that are on perfect corners. What I mean by that is perfect corners of the grid. So for this example, I'm going to choose this point right here, and I'm feeling like this point right there, because they are on, I think those are the only 2 on this graph that are on perfect grid corners. Okay. So I'm going to label my graph with L, whoops, I forgot to change my marker to the skinny one. There we go. So I'm going from left to right. Now to go from left to right this time, I'm going to have to travel up. So let's see how many I need to go up. And let's make this marker a little less thick so I can use it on my graph nicely. Okay. So I'm going to go up 1, 2, 3, 4, 5, 6, 7. Since I'm going up, I'm going to have the 7 remain positive. And we're always traveling to the right. So let's see how many I have to go to the right now. 1, 2, 2. So our average rate of change is 7 over 2. Fortunately, or maybe unfortunately, depending on how you feel about fractions, we cannot reduce this. So onwards we go. Let's calculate the average rate of change for this function. So I'm going to remind myself, rise over run. I'm going to pick 2 points, label them as left and right. Okay, so I'm feeling this point right here because it's at the corner of a grid. Oh, and there's one very close by, right there. Perfect. Okay, I'm going to label this as my left point, and this is my right point, so I remember which way I'm going. Okay, so it looks like from left to right, I'm going down, so I'm going to have a negative slope. So let's see how that goes. I need to just go down 1 to be at the same level as the point on my right. So my rise is actually -1 because I went down 1. And now let's see how many spaces I need to go to the right to get to my next point. 1, 2, 3. 3 to the right. So my average rate of change is -1 over 3. The bottom number is always going to be positive because we're always going to travel to the right. That's how we assure it. So I always recommend picking a point on the left and going to the right. That way you can stay consistent and go from and always have the bottom of our average rate of change a positive number. Now, we can always also look at average rate of change without a graph, and we can use a table. So here is the official formula for average rate of change. Now, that little triangle that you see is actually called a delta. So delta y over delta x. Now, what the delta means in math shorthand is the change in. So the change in y's over the change in x's, which is actually what we were just doing. The change in y's is up and down. That's a rise. The change in x's is left and right. But because we're not looking at it on a graph, we need to kind of explore that further by labeling the x's and y's. So to find the change in y's, our rise, we do y2 minus y1, and for x's we do x2 minus x1. Let's see what that means on our table. Okay, so here we have x's, and I know you don't see any y's, but let me remind you that f of x is y. It just says that this line, this table, is a function. So instead of y, we write f of x. All right, so the x's are on top. Let's use purple. I'm going to call this x1 and this one x2. And then for the y's, I'm going to call this y1 and y2. Make sure you're consistent. Right? X1s should be with y1s and x2s should be with y2s. All right, let's do this. Change in y over change in x. All right, so find the changes in y's. We do y2 minus y1. Let me make the minus black, yes. And then x2 minus x1. Let's make that purple marker a little skinnier. There we go. All right, so my y2 is negative 6 minus y1 is negative 12. Okay. For the x's, I have 0 is x2 minus my x1 is negative 3. All right. So let's use our calculators. Negative 6 minus negative 12 is positive 6. Whoop. Oh, no. Okay, that's a black marker. And 0 minus negative 3 is positive 3. We can reduce this. Yes, we can. We can divide the 6 and 3 by 3, which allows us to have an average rate of change of 2 over 1. And, of course, you can write that as a whole number, too. All right, not too bad. Let's try it one more time. Again, we have a table, and I'm going to remind myself that f of x equals y. I'm going to label this as x1, x2, y1, y2. And I'm going to calculate the change in y's over the change in x's. All right, so on the top of my change in y's, I have y2 minus y1. On the bottom, I have the change in x's, x2 minus x1. All right, let's do some subtraction. y2 is 0, y1 is 5, x2 is 13, x1 is 15. All right, 0 minus 5 gives us negative 5. And 13 minus 15 is negative 2. And I would like to remind you that a negative over a negative makes a positive. They cancel each other out. So we have just positive 5 over 2. And that's as far as we can reduce that. All right, so average rate of change, not too bad. But what we're going to do next might seem a little new, but I think it will jog your memory from doing some equations in algebra in middle school. So let's take a look. All right, so a tree is currently 10 feet tall and grows 2 feet per year. Model this scenario with an arithmetic sequence in explicit form. we just did that. The explicit formula is an equals a1 plus dn minus 1. Okay. Our a1 is our first term, so what we start with. So our tree is currently 10 feet tall, so 10. D is our common difference, our pattern. It grows 2 feet. That means plus 2. Cool. All right, letter B. Rewrite the explicit form of the sequence using function notation. Okay, so function notation. Function notation has f of x. So instead of an, I will write f of x. Okay. 10 is 10, that's a number. 2 is 2, it's a number. But because we're not using n's anymore, we're using x's, I'm going to write x minus 1. We need to continue this. Now here's where I'm going to jog your middle school memory. When we have a number in front of parentheses, we do something called the distributive property. And this is multiplication. So the 10 plus stays the same because there's no parentheses next to it. All right, 2 times x is 2x. 2 times negative 1 is negative 2. Now, we're not quite done. We have one more step left. We are going to combine like terms. Now, when we combine like terms, we can only combine things that look alike. Now, in this part of the equation, I see 3 things. 2 of them are similar. The 2 things that are alike here are the 10 and the negative 2, because neither of them have x's. The 2x has an x, so there's no other x's to combine with. It stays 2x. 10 and negative 2 combine to make positive 8. So, in the end, whoops, that didn't convert from highlighter yet. Okay, there we go. We have f of x equals 2x plus 8. How tall will the tree be in 5 years? Now, when it says 5 years, it wants us to plug 5 in for x. So instead of x, we have 5. So instead of f of x, we have f of 5, which means instead of 2x, we have 2 times 5 plus 8. 2 times 5 is 10 plus 8. 18 feet is our answer. Number 6. A tree is currently 4 feet tall and grows 6 feet per year. Let's model a scenario as an arithmetic sequence in explicit form. Okay, let's first write down the explicit form, which is an equals a1 plus dn minus 1. Okay, let's figure this out. We'll have an equals. a1 is our first term. The tree is 4 feet tall, so 4. D is our common difference, our pattern. It grows 6 feet, so plus 6. And n minus 1 stays n minus 1. B. Rewrite the explicit form of the sequence using function notation. Okay, that means we have to use f of x. No more n's, just x's. So instead of an, I'll have f of x. 4 stays 4 because it's a number. Same with 6, but the n changes to an x. Once again, we're going to continue simplifying this by using the distributive property. Now the 4 plus stays 4 plus because there's no parentheses attached to it. Nothing telling us to distribute or do anything else. But we're going to take that 6 and distribute it. 6 times x is 6x. And 6 times negative 1 is negative 6. We have to continue simplifying this because I see 2 like terms. Hopefully, you also see that 4 and negative 6 are the like terms that we're combining because the 4 and the minus 6 do not have x's. the 6x does, so it stays 6x. Unfortunately, all on its lonely. But 4 minus 6 gives us negative 2. Okay, so function notation, f of x equals 6x minus 2. All right, one last thing that we need to do is find out how tall this tree is in 10 years. So that means instead of x, we're going to plug in a 10. So f of 10. Instead of 6x, we'll have 6 times 10 minus 2. 6 times 10 is 60, and 60 minus 2 is 58. So 58 feet. I hope this was helpful, and if you have any questions, please make sure to ask me. Yeah, have a wonderful rest of your day. Bye!